Hi everyone, this is our lecture on the fasted versus fed state. So let's get started. To get a clinical perspective, let's look at a quick flash case. Let's say a 34-year-old female presents to the clinic for her annual wellness visit. She states she has felt tired in the past week and asks if her fatigue could be related to her new diet, which involves fasting for certain periods of time. Let's keep this in mind as we go through the lecture. Our learning objectives are to define the fasted state and the fed state, differentiate metabolic processes in the fasted versus the fed state, and to recognize the role of the adipocytes in the fasted state and the fed state. Okay, we need to get some terms straight first. The fed state starts as you eat and continues as you digest and absorb food. When you eat, insulin stimulates the storage of lipids and glycogen. It's similar to preparing for bad weather, a hurricane, a tropical storm, or snowstorm. Under normal circumstances, we have food and water and toilet paper in good supply and accessible to us. But just in case, maybe we'll get an extra box of crackers or an extra gallon of water to keep in storage. We expect to eat again, but just in case we don't, we're going to keep some stored. That's what insulin wants you to do. Now, in the fasted state, which starts hours after your last meal, the body's priorities are different. It's wondering if that meal is coming, and it's getting a little anxious. But no matter what, it knows it has to supply sufficient glucose to the brain and red blood cells and to preserve protein. We don't want to break down muscle if we don't have to. The hormones glucagon and epinephrine stimulate the use of our fuel reserves. I hope this overview makes sense. So let's repeat what I just said with a little more detail, and let's focus on what's going on in the blood and the adipocyte. So first, let's walk through the fed state. When you eat, you increase your blood glucose, and insulin is released from... Where is insulin released from? Yes, it's released from the pancreatic beta cells. So once insulin is in the blood, remember, one of the anabolic effects of insulin is to increase glucose transport into the adipose tissue. So, with the help of insulin, glucose will go into adipose. Can you remember which transporter this is? It's our insulin-dependent glucose transporter. If you're saying GLUT4, that's fantastic. Can you remember what other location other than adipose tissue has the GLUT4 transporter? If you're saying striated muscle, that's very good. Okay, back to this glucose. What's going to happen to it now with respect to the adipocyte? Well, it's going to undergo glycolysis and a series of reactions until it becomes dihydroxyacetone phosphate, or DHAP, and then get transformed to glycerol 3-phosphate with the help of glycerol 3-phosphate dehydrogenase until it becomes a triglyceride in storage. Okay, let's go back to insulin in the bloodstream. Can you remember another way that it helps in triglyceride storage? Well, when we consume dietary fat and cholesterol, they get transported into the systemic circulation in a chylomicron. And ApoC2 on the chylomicron activates LPL, or lipoprotein lipase, to break it down into free fatty acids to join with glycerol to create triglycerides in the adipocyte. Now, here's a throwback image you may thought you'd never see again. Can you recognize it? You're right if you're saying it's the structure of a triglyceride, made up of glycerol and 3 fatty acid chains. Can you remember what pathology can occur with an ApoC2 or lipoprotein lipase deficiency? You're right if you're saying a familial dyslipidemia. Type 1 specifically, or hyperchylomicronemia, which is autosomal recessive. Okay, I know that was a lot, but that was just the fed state. Let's look at another adipocyte, but this time in the fasted state. Remember, the fasted state starts hours after your last meal, and the body's priorities are to supply sufficient glucose to the brain and red blood cells, and to preserve protein. Can you remember which hormones stimulate the use of our fuel reserves? Yep, they are the hormones glucagon and epinephrine. This is the whole reason we stored those triglycerides in our adipocytes, for these moments. What does that triglyceride break into? What is it made of again? Yes, it breaks into free fatty acids and glycerol, which can then go into the blood to be used as fuel, like in gluconeogenesis, for example. Can you remember what enzyme is responsible for degrading triglycerides stored in adipocytes? Yes, you're right if you're saying HSL, or hormone-sensitive lipase. When epinephrine and glucagon are around, hormone-sensitive lipase breaks down triglycerides stored in adipocytes. And for our last correlation, can you think of a lipid-lowering agent that inhibits hormone-sensitive lipase? It's really great if niacin came to your mind. Okay, let's check what we just reviewed. Which hormone stimulates the storage of lipids, proteins, and glycogen? Yep, it's insulin. Let's do one more. Which enzyme breaks down triglycerides in the circulating chylomicrons? Great, it's lipoprotein lipase. Let's get back to this case. Our patient wants to know if her fatigue could be due to her new diet, where she's fasting for certain periods of time. This is a common situation, and it's very important to get more details about her diet, like what she is or isn't eating, how long she's been dieting, her reasons for dieting, her timeline, and if she's using any supplements or additional dieting strategies alongside her changed food intake. It's why those patient interviews and histories are so crucial. I know most of us fast for quite a while without any significant symptoms, so while this case is missing a lot of details, just know it's here to trigger your thoughts to compare and contrast the fasting and the fed states. Remember, our priority is always to supply enough glucose to the brain and red blood cells, and if the brain isn't getting enough fuel, this could be a reason she's feeling tired. Well, we've made it to the end. What's the bottom line? In the fed state, insulin stimulates storage of lipids, proteins, and glycogen, including the storage of triglycerides in adipocytes. In the fasted state, glucagon and epinephrine stimulate the breakdown and usage of fuel reserves, such as breaking down triglyceride stores in adipocytes. That's all I have for you here. Please give this video a thumbs up if you liked it, and it'll give you the opportunity to submit a comment if you have any feedback or questions. Thanks for joining me. Study hard.